In this video, we're going to look at another example of finding the area of a region in between two curves. So we're being asked to find the area of the region enclosed by 4x plus y squared equals 12 and x equals y. Notice that the 4x plus y squared equals 12 is this parabola that's opening to the left here. This is not a function of x, however, it is a function of y. You could solve this equation for x, you would get, what, 3 minus 1/4 y squared? So we would have x as a function of y. And notice that our left bounding curve and our right bounding curve would be the same throughout the entire region. So it's going to be easier in this case to integrate with respect to y than it would be to integrate with respect to x. If you were to try to integrate this with respect to x, you'd have to split it into two integrals, because notice we have this line is above this bottom curve of the parabola all the way until you get to this point of intersection, and then we've got this top part of the parabola being above the bottom part of the parabola. So it really is going to be easier to do this in terms of y rather than an x, because we can do it with one integral instead of two. All right, so much like what we did in the previous video, we're going to set these two things equal to each other and figure out the y coordinates of the points of intersection. We want the y coordinates in this case because we're going to integrate with respect to y. So we need y bounds for our integral. So since we're looking for this to be on the curve x equal to y and 4x plus y squared equals 12 at the same time, we can just substitute y for the x and solve for the y. So we're solving this by substitution. Moving everything all to one side, we get y squared plus 4y minus 12 equals 0. Factor that and figure out that our y coordinates of the points of intersection are -6 and 2. So the -6 will be our lower limit of integration. The 2 will be our upper limit of integration. And remember, when we're integrating with respect to y, we're going to use our right curve is the bigger curve and the left curve is the smaller curve, because these x values here would be bigger than the corresponding x values on the left curve at the same values of y. So instead of doing a top minus bottom, we're doing a right minus left. So again, here solving for x, we got the 12 minus y squared over 4, or again, 3 minus 1/4 y squared, and then minus y. So we're doing right minus left. So here's our integrand. Find an antiderivative here. We get 3y minus 1/2 y squared minus 1/12 y cubed. Put in your upper limit of integration. Subtract off what you get when you put in your lower limit of integration. Simplify this arithmetic, and you should get 64 over 3.